So this is June 2018, Unit 2. I'll discuss multiple choice questions, MCQs. The first question, which species do not have a trigonal pyramid? So you have to identify the structure, how you can identify the structure by identifying the number of the bond pair and the lone pair. Trigonal pyramidal means it should have 3 bond pair and 1 lone pair. Because this structure, trigonal pyramidal, exists when there are 3 bond pairs and there is 1 lone pair. So we have to check which molecule does not have bond pair and like 3 bond pair and 1 lone pair. So it will not be trigonal pyramidal. So AlCl3, when we draw AlCl3, aluminum trichloride. So 3 bond pairs are there and there is no lone pair. So 3 bond pair, no lone pair, so it will not be trigonal pyramidal. BNH3, when we draw NH3, nitrogen share 3 electrons with hydrogen. And there is 1 lone pair on nitrogen, so 3 bond pair and 1 lone pair, it will be trigonal pyramidal. Same thing, H3O. So it has 3 bond pairs and 1 lone pair is there, so that will be trigonal pyramidal. And PCl3, phosphorus belongs to group 5, so it share example 3 with chlorine, the central atom, and 2 unpaired electrons are there, so 3 bond pair, 1 lone pair. So all these 3 will be trigonal pyramidal because they have 3 bond pairs and 1 lone pair. Whereas in AlCl3, it will not be trigonal pyramidal because it does not have a lone pair. Which molecule contains 3 atoms in a straight line? So it means they're asking which one is the bond angle. Example, when we draw the structure for each, so 3 atoms, we'll find them in a straight line. We can say like 180 degrees will be there, the total bond angle. So BF3, boron tetrafluoride. So this is a structure of BF3. So what is the bond angle? The bond angle is 120. So they're not in a straight line. CH4, carbon, methane is there. So carbon, the bond angle will be 109.5 tetrahedral structure. So the 3 atoms are not in a straight line in CH4. H2O, oxygen is having 2 lone pair and 2 bond pairs are there. So it is a bend or a V shape with a bond angle of 104.5. And SF6, sulfur hexafluoride. So when we draw each, the bond angle is 90. So if the bond angle is 90, if this bond angle is 90, so this will be 90 and this is also 90. So what is, you can see the 3 atoms are in line. So D is the right answer. Is it clear, this question? Then which compound has a greatest ionic character? Greatest ionic character means it should have a greater difference in the electronegativity. So electronegativity, what happens as we go, like group 7 elements are there. So electronegativity decreases as we go down the group. Like fluorine is there, chlorine, bromine, and iodine. So as we go down, what happened to electronegativity? It decreases. It becomes less electronegative as we go down the group. So sodium with fluorine will have the greatest difference in the electronegativity as compared to sodium with chlorine, bromine, or iodine. So which will have the highest ionic character, greatest ionic character, that is C. So ionic character depends on, this term ionic character depends on difference in the electronegativity. Greater difference in the electronegativity means greater ionic character. In question 4, which best represent the position of a bonding pair of electron and dipole of hydrogen chloride? So because chlorine is more electronegative, if chlorine is more electronegative, chlorine will have a greater tendency to attract electron. So these electron pair which are shared between chlorine and hydrogen are shifted more towards chlorine. So in which diagram they're shifted more towards chlorine, A or C? And then if they are shifted more towards chlorine, chlorine will be partial negative and hydrogen will be partial positive. So that's why A is the right answer. Why C is wrong? Because they mentioned chlorine to be partial positive. It will not be, because if electron is shifted more towards chlorine, it should be partial negative. When a system is at equilibrium, which statement is always true? So equilibrium or a reversible reaction, when rate of forward equals to rate of backward, we call that system is in equilibrium. So what we can say, there will be no change in concentration of amount of reactant and product. So concentration of reactant and product will remain unchanged or constant. And what is the definition of oxidizing agent? Oxidizing agent by itself, it is reduced, and reduce means reduction means gain of electron. So the substance which gain electron, it is reduced, that we call that as oxidizing agent or oxidant. And reducing agent, the substance which is oxidized or lose electron. In question 7, which trend is correct when we go down the group 2 for atomic number, as atomic number increases? So atomic radius decreases, no, that increases. Electronegativity increases, electronegativity decreases. First ionization energy decreases, that is true, because the size of an atom, as we go down the group, the size of an atom is increasing. So if the size of an atom increases, the electronegativity, the first ionization energy decreases. Like it becomes easy to remove electron from the larger atom as compared to smaller atom. So C is the right answer. And thermal stability of nitrate, thermal stability, nitrate, carbonate, sulfate, they all increases as we go down the group. Consider the following reaction energy profile. The activation energy of the following reaction has a value of activation energy. How to work out the activation energy? Basically, activation energy, energy needed to start up the reaction, the minimum possible energy at which the reaction start, we call that as activation energy. So how I can work out the activation energy? Like if I say this is say 100, this is 80. So what is the activation energy? How much energy I need to start the reaction? So it will be X minus Y, like 100 minus 80. So it will be 20. So A will be the right answer. In question 9, a white solid give a lilac color. So if it give a lilac color, this gives an idea that there is a potassium is there. And the solid react with the water, forming a strong alkaline solution. So it's a metal oxide should be there, because metal oxide mixed with water, it will form an alkaline, not a salt. So it cannot be C or D. So either A or B, but because lilac color gives an idea, it should be potassium. So that's why it is B. Because metal oxides, when dissolved, form an alkaline solution or a basic solution. In question 10, which of the following is an isomer of 2,2-dimethyl pentane 1-ol? So to identify the isomer, first you have to know how many carbon atoms should be there in 2,2-dimethyl pentane 1-ol. So when I draw the structure of pent means 5 carbons, so 1, 2, 3, 4, 5. And 1-ol means first position OH group is attached, and two methyl dimethyl. So two methyl groups are attached. So this will be CH2, this will be CH2, this will be CH2, and this will be CH3. So when we draw the structure, so how many carbon should be there? 1, 2, 3, 4, 5, 6, and 7 carbon should be there. So 1, 2, 3, 4, 5, 6. So A cannot be an answer because it is having 6 carbon atoms. When we check B, or if we like, first we should count the number of carbon 1, 2, 3, 4, 5, 6, 7. So this can be 1, 2, 3, 4, 5, 6, 7, 8. So this cannot be an isomer. 1, 2, 3, 4, 5, 6, 7, 8. So this cannot be. So simply because to be an isomer, it should have the same number of atoms, like same molecular formula, different structure. So without even drawing the structure, I can recognize that it is B, because B is having the same number of carbon and hydrogen and oxygen atoms. Then which of the following hydroxide is the most soluble in water? Solubility increases as we go down the group for hydroxide. So down the group, as we go down for, so we have barium is, when we check the periodic table, like we have magnesium, calcium, strontium, and barium is there at the bottom. So barium hydroxide will be the most soluble. So A will be the right answer for this, because solubility of hydroxide as we go down, it increases. Question 12, under suitable condition, a mixture of a carbon monoxide and hydrogen react to form water in a mixture of hydrocarbon. What is the general formula for the hydrocarbon produced? So how we can work out, because the equation must be balanced. So if number of the carbon, as you can see here, the number of the carbon are N. So the hydrocarbon, it should be Cn. Then how many hydrogen are there? Total number of hydrogen. The total number of hydrogen are 2N plus 1 hydrogen into 2. These are the total number of hydrogen on the left hand side. So on the right hand side, we have on the right hand side, we have N hydrogens, NH2 hydrogen. So how many, if we work out, like, because if you take the difference of the two, like this is on the reactant side, minus, to know how many hydrogen should be here. So reactant side minus the product. So when I subtract product, so it will be NH2. So when we simplify, this will be 2NH2 plus H2 minus NH2. This 2NH2 will cancel with H2, so it will be NH2 like when we subtract, so it will be NH2 plus H2, or we can also say, because the ratio 2NH2, like NH2 plus H2, if I take H common here, so it will be N plus 1 H2. And then because we want to find how many hydrogen are there, so number of hydrogen will be twice of this. So I can say 2N plus 2 H will be there, because we want total number of hydrogen. You can solve in this manner, or there's also another way, like you multiply this, because total number of hydrogen you're finding, so you multiply this 2 here. So 2 multiplied by 2, 4N, and this 2 is also multiplied plus 2. And on the right hand side, this is 2N. So left hand side is 4N plus 2, and the right hand side is 2N. When you subtract to know how many hydrogen should be here, so when you subtract them, 4N plus 2N minus 2N, so it will be 2N plus 2. So hydrogen should be 2N plus 2. And carbon should be N. Because the total number of, for a balanced equation, total number of atoms on the right and the left should be equal. So it is 2N plus 2 and Cn at 2 H2N plus 2. So D will be the right answer. So a protective layer of ozone exists in the atmosphere. The protection mainly arises from ozone ability to, what is the ability of a ozone, like the protective layer of ozone exists in the atmosphere. This protective protection may mainly arise from ozone is ability, because what happened, it can easily break down. So it can easily, like it absorb the UV light or ultraviolet light and break down into oxygen and ozone, or oxygen radical, oxygen molecule and oxygen radical. So not to reflect it is to absorb ultraviolet radiation, not break down chlorofluorocarbon, that is different. It has a tendency to absorb ultraviolet radiation and break down into oxygen molecule and oxygen atom. In question 14, consider the following equation. The value of n is required to balance the above equation. So how many electrons should be there? Because the total number of charge on the left and the right hand side should be equal. Chlorate is having -1 charge. Hydrogen ion is plus, so 6 are there, so +6. Here we have -1 and water is neutral. So we want the total charge to be -1. Right now, -1 plus 6, so it is +5. We want a -1. So how it can be -1? So if I add 6 electrons should be there. If -6 or 6 electrons are there, so net charge will be -1. So what should be the number of electrons according to this equation? It should be 6 electrons. So the total charge will be -1. In question 15, the conversion of butanoic acid to butane-1-ol is an example. So alcohol, carboxylic acid convert to alcohol, so that is called reduction. Because alcohol oxidized to aldehyde and then to carboxylic acid. So if carboxylic acid is converted back to alcohol, we call that as reduction reaction. Compound X forms a compound X forms compound Y in a reaction. So X is forming a compound Y as shown. So basically, what happened, like this is a element, this is a esterification, ester is formed, so compound Y is an ester. What mass of a compound X is required to produce 8.4 grams of compound Y? The yield, if the yield is 40%. So what is the ratio of the mass? If we have like 138, like we'll find first the practical, the theoretical value. If we have C7H6 and O3, and it is forming one molecule of C9H8 and O4. So ratio of the mass is 138 is to 180. So if we have because in the question we need what mass of a compound X is required. So first we are finding the theoretical using a percentage yield. So percentage yield is equals to the practical value of the product divided by theoretical value into 100. So percentage yield, that is 40%. Practically, we are getting 8.4 grams. So practically, we are getting 8.4 grams. Theoretical value of the product, we don't know, into 100. So we cross multiply the theoretical value. So the theoretical value of a product equals 8.4 multiplied by 100 divided by 40. That will give us theoretically how much product should be there. And from theoretical product, we'll find theoretical, like the total reactant. So 8.4 times 100, and that is divided by 40. So means theoretically, we should have 21 gram of a product. So 138 is 180. So if we have 21 gram of a product, how much reactant should be there? X. We cross multiply. So X is equals to 138 times 21 divided by 180. So 138 times 21 divided by 180. That will give us 16.1. So we should have 16.1 grams of a reactant to get this product. In question 17, which alcohol can be oxidized by acidified potassium dichromate to form ketone? Ketone can be formed by secondary alcohol because secondary alcohol can be oxidized. Tertiary cannot be. Primary will oxidize to aldehyde and then to carboxylic. So when we check the different alcohols here, the first one is a primary alcohol because the carbon is attached and there is one whole carbon chain, so it's a primary. The second one is a secondary alcohol because two carbon chains are attached, so this will be oxidized to ketone. The third one is a tertiary, this is a carbon, it is attached with three carbon chains, so it is a tertiary. It cannot be oxidized at all. And the fourth one is again, like this whole is one chain. So the fourth one is also a primary. Primary will oxidize, but to aldehyde and then to carboxylic acid. In question 18, an experiment required 500 cm³ solution of with a nitrate ion concentration 0.1 mole per dm³. This is prepared by diluting 0.250 mole per dm³ calcium nitrate. What volume of a calcium nitrate solution will be needed? So look, experiment required 500 cm³. This is a volume of solution which we need. And the nitrate ion concentration, the concentration of a nitrate ion should be 0.1. So this is the concentration. So first we will find, using this, we will find, because the concentration is there, volume, so we'll find how many moles of nitrate are needed. So moles equal concentration into volume. The concentration is 0.1 and the volume is 500 cm³, but divided by 1000, so it will be 0.5. So 0.5 times 0.1, that is 0.05. So 0.05 moles of nitrate are needed. And we have, this is prepared by diluting a solution which is having a concentration of 0.2 calcium nitrate. So if calcium nitrate CaNO3 in a bracket 2, so it contains calcium ion and it contains nitrate ion. So how many nitrate ions are there? 2. So the ratio of the moles for calcium nitrate to nitrate ion is 1:2. Like if we have 1 mole of calcium nitrate, it will have 2 moles of nitrate ion. So if we have 0.05 moles, then how many moles of calcium nitrate will be there? X. Cross multiply. Because we have the concentration of the solution, we will find the moles of calcium nitrate, and using moles of calcium nitrate, we can find the volume of the solution. So 1:2 is the ratio between calcium nitrate and nitrate ion. So 0.05, this will be X. So we'll cross multiply. So 0.05 divided by 2, that is 0.025. So 0.025 moles of calcium nitrate are needed for this. So we need 0.025 moles of calcium nitrate. Now we need the volume. Moles equal concentration into volume. So volume is equals to moles divided by concentration. So moles are 0.025 divided by concentration is 0.25. So 0.025 divided by 0.25, that is equals to 0.1. So volume of the solution is equals to 0.1 decimeter cube. Decimeter cube but all the answers are in cm cube, so we have to multiply by 100 1000. So if you multiply 0.1 by 1000, so it will be 100 centimeter cube. So B will be the right answer for this. Question 19. A mass of 1.6 grams of anhydrous metal sulfate was dissolved in water. The addition of excess of barium chloride result in a precipitate 2.33 grams of barium sulfate. The original substance could be, like, this is a mass, original 1.6 grams of anhydrous metal sulfate was dissolved in water. And addition of excess of barium chloride, when we add a barium chloride, it form a precipitate 2.33. So what could be the original substance? So we have to work out according to the change in the masses, like example, writing a balance equation. So if it was a calcium sulfate, first thing, it cannot be calcium sulfate. Why it cannot be calcium sulfate? Because barium, calcium, and lead sulfate, they are insoluble. So A cannot original, because in the question 1.6860 grams of anhydrous dissolve in water. So calcium sulfate is insoluble in water, cannot dissolve. So we are left with copper, magnesium, and so it can be either copper sulfate, CuSO4 will be there, or either it will be magnesium sulfate, or it will be sodium sulfate. And when it mixed with barium chloride, BaCl2, so this is not there, like calcium cannot be an answer because calcium sulfate is insoluble. So if we mix with barium chloride, BaCl2, this one, if we mix with BaCl2, and here also we mix with BaCl2, what it will form? It will form copper chloride, and it will produce barium sulfate, which is a PPG. When this will dissolve, mix, it will produce magnesium chloride, MgCl2, and it will produce barium sulfate. And when this will mix with, so it will produce sodium chloride, 2 moles of sodium chloride, plus barium sulfate, so BSO4 will be there. Okay. Now the question is, the equation must be balanced, so equation is balanced. So if this anhydrous sulfate, like 1.6 gram, if it was copper sulfate, so what is the mass of a copper sulfate, CuSO4? So 1.6 divided by copper sulfate, copper is 64, sulfur is 32, and oxygen is 16 multiplied by 4. So it will be 1.6 divided by 16 times 4 is equals to 64, and 64 plus 32, 96 plus 64, that will be 160. So 160. When we divide 1.6 divided by 160, that is 0.01. So 0.01 moles are there. So you can clearly see, like example, you can take a ratio of the mass, like, or you can first find the moles and take the ratio of the moles. If I take the ratio of the mass, if I have, like, copper sulfate is, the mass of copper sulfate is 160. And the total mass of barium sulfate, 1 mole of barium sulfate is 233, that is given already. So 160 is to 233. So if I have 1.6, so how much will be there? X. I cross multiply. How much I will get? I will get 2.33 grams. So that's why B will be the right answer. Why not magnesium sulfate cannot be an answer? because the mass of magnesium sulfate, magnesium is 24, sulfur is 32, plus oxygen 16 multiplied by 464, plus magnesium is 24. So the ratio is 120 for magnesium sulfate. If it was a magnesium sulfate, the ratio will be 120 is to 233. So if we have 1.6, then it will be X. So 120, so this does not give the same desired value. It does not give 2.33 gram. It will give a smaller value. So using the mass ratio, we can work out the mass of the precipitate produced. In the last question, the concentration of a solution of iodine can be determined by titration with solution of sodium thiosulfate. The sulfur containing product for this reaction, like the iodine thiosulfate reaction when it occurs, because this reaction is when iodine I2 reacted with 2 molecules of S2O3, it produced 2 iodide ion and it produced S4O6 with a charge 2 minus. So this is the ionic equation, like aqueous is there. This is aqueous. This one is iodine liquid, here aqueous, and this also aqueous. So this is ionic equation. But so the product which contains sulfur, that is S4O6, and this is having a charge of -2. So overall equation, because if you use sodium thiosulfate, if sodium thiosulfate is used, so the reaction between them will be iodine plus Na2S2O3 gives 2 iodide ion and produce Na2S4O6. So Na2S4O6, so B will be the right answer. So this was the exam paper from June 2018.